Okay, ladies and gentlemen, we've dealt with conics, with circles, hyperbolas, ellipses, and parabolas, together with their general forms and their general equations. Now what we need to do is we need to look at each shape individually. We're going to go ahead and start with parabola. Now, the parabola, the key to it is it only has one squared term. Y equals x squared, x equals y squared. Only one term is squared. So in essence what we're going to do is we're going to take the general form and we're going to eliminate the squared term so that I only have one squared term with some tag-alongs equals some y and some number. So in our case we have x squared plus 2x plus y minus 3 equals 0. To do this problem, I'm going to need to put it in a more standardized form. But even before I start, I can tell this parabola is either going to go up or it's going to go down. I don't know which. It could be this one or it could be this one. But I know it's going to be vertically oriented because for every one y, there's going to be two x's. So if I go up to any y value, I'm going to hit the graph twice. So 2x's for every y. Important to know, if this were 1x with y squareds, it would be going horizontally, the other way. So what we need to do at this point is let's get this into the standard form we know. X minus h, the quantity squared, equals 4p parentheses y minus k. That's what we're aiming for. To turn this into this, we're going to have to complete the square. That was the whole point of our completing the square mini lesson. Now, when we did completing the square, we said, all right, fine, let's get the x stuff by itself with a blank by moving the rest of this over to the other side. So subtract y, add 3. Now, to complete the square, you take the middle term, divide it by 2, and square it. That's going to be 1, but if I put a 1 over here, I have to put a 1 on this side to balance it out. So I have x plus 1, the quantity squared, equals negative y plus 4. Now we're real close. I have x something h squared equals, I don't really have the 4p yet, but I'm going to get it, y minus k. To do that, I need to get y with a coefficient of 1. Right now it's negative 1. Let's factor out that negative 1. And I come up with this. At this point, I know it's going to be vertically oriented. I know that whereas the parabola should be centered at 0, 0, the plus 1, just like in every other equation we've done, moves it left 1 unit. Now, y minus 4, well, you'd say, well, then it should go down 4. But remember, if this were x minus 1, it would have moved right 1. So y minus 4, you say, what would go in here to make this 0? What minus 4 would be 0, and that is positive 4. 1, 2, 3, 4. Now, usually a parabola is focused up, but because of this negative, like every other negative that we've done, it's going to go down. So our parabola looks something vaguely like this. The only thing I'm not sure about is how wide or how skinny this parabola is. That's where the 4p comes into play. The 4p is going to give us two important pieces of information. The 4p is in front of whatever the y parenthesis is. So what's in front of our y parenthesis? Negative 1. So 4p equals negative 1. Meaning that if I solve, p equals negative 1/4. Well, the negative simply indicates that it's going to be down or opposite of its intended direction. So we got that part already. The 1/4 is an important piece. The 1/4 says from the vertex, you need to go up 1/4 of a unit. So whereas the vertex was at negative 1, 4, This line here is going to be up a quarter, so it's going to be y equals 4 1/4. Now, this is called the directrix. The directrix is y equals 4 1/4. This is a line that the parabola will approach but not touch. It's going to be balanced by a point on the inside. That point on the inside is going to be down a quarter. So, if we were to look only at this vertex, we're going to go up 1/4 to the directrix, and we're going to go down 1/4 to this point here called the focus. The focus in our case is going to be a quarter unit below the vertex. So again, I would say -1, 4 minus 1/4 equals -1, 3 3/4. That's the focus. If you think about it, it's in essence a magnet drawing it in, but a line of a wall, another bar magnet pushing away, so you have the balance of these forces that creates this curve. So we'll talk a little bit more about parabolas in the next video.